Okay, now you finished learning about all the different types of relationships for numeric and categorical data. There's still one more step though. What we did is a pretty standard process that we do for every single data mining project to explore and understand the basics of the relationships, assumptions, cleanliness, and all that. However, the purpose of this wasn't just to deliver a report to someone. The purpose was to understand what's going on with the data, and when we do this, we often have some interesting findings that aren't fully explained yet, that need more than two variables examined at once to really understand. And in particular, we see this a lot with scatter plots. So here's the scatter plots we developed. It was really chiefly age, BMI, and children. So children, this one was pretty straightforward, being a discrete variable. It appears that having more kids increases charges. However, we've got less data up here. There's still some data spread out over here that we don't fully understand, but there's nothing too concerning about children. Let me go to BMI. BMI, we had some concerns because there's this clear section up here that was breaking off from the group, where as BMI increased for the vast majority, it didn't change charges. However, there's a group up here that it surely does change charges for. Before we address that one, let's take a look at one more. Age. Here was where we had some real interesting questions. Clearly, three distinct groups, and our regression line and our correlation, none of those things explained what was going on here. So what we need is to enhance our bivariate analyses or relationships with 3D, 4D, 5D, 6D relationships. How do we do that? Well, we need to start adding more variables to the chart. So let's actually start fresh out here. I'm going to call this ND for any number of dimensions. We'll call it charges. Actually, no, I'm going to call it age scatter. So let's pull age in again and charges. And let's deaggregate the measures. Let me reverse that. And let's see what we can come up with. What we need to do is add a few more variables until we clearly explain or find a difference among these groups. So what I learned going through our data exploration report, let me pull that up again here, was that we had this huge effect of smoker and a huge effect of age. So among the numeric features, age was our biggest indicator, and among the categorical, it was smoker. So I'm going to start with smoker. Knowing how big that one was, by coming here and grabbing, right up here, smoker, I'm going to add it to, nope, not rows. Oh, not there. I want to add it to color right here in the marks. So I mess things up by, no, I moved charges. There we go. I want smoker on color. There we go. Sorry about that. Age and charges still up here. I want smoker dropped on color right there. And see what this shows us. Everybody up here in this high area is orange. Meaning what? Well, let me minimize that. Here's our legend. Orange are yes, blue are no. So when we look at three variables like this, again, charges are labeled, and we have two features, age and smoker. There are a couple ways we can interpret this. So one, we could say that there could be an interaction effect, which means that the effect of one feature is compounding or hiding or eliminating the effect of the other. Sorry, not eliminating or hiding. It's either compounding or reducing the effect of the other across different values. Meaning, as age increases, does the effect of smoking change the direction of the chart or the variance or the spread? Now, in this case, we can see that, yeah, there's a clear differentiation here. Non-smokers are, everybody in the high level here are non-smokers. Everyone in the low level, I've got it reversed. Everyone in the low level of costs are non-smokers, high level are smokers. However, the variance is still pretty consistent as far as how it's spread out over age. So I wouldn't say that there's an interaction effect between age and smoker. What we do have, though, is simply another feature, smoker, that's explaining why we have these three distinct chunks, at least the top and the bottom. The middle one here isn't really helping. We have a pretty thorough mix of both blue and orange, other than I would say the orange is has a bit more of a consistent line through there, whereas the blue is a bit more spread out. But still, the spread of variance on both the blue and orange seems to be consistent across values of age. Although it's increasing, the spread stays pretty close to the same. So smoker has helped, but it hasn't told us everything. It's explained the top and the bottom, but not the middle. All right, well, what else can we do to add another dimension to this chart? Let's get, let's just try a few. Let's grab sex here, and let's put that on, let's put it on shape. So now we have males are squares, females are circles. What I'm looking for is if there's a clear difference between squares and circles on this middle section, to see if that explains what's going on. Well, what I can do to help this is I'm going to grab this section right here, and can I zoom in on that a little bit? Let's see here. It looks to me like I've got a pretty even mix of squares and circles still. I don't think sex is really explaining it. So I'm going to pull that one back out. And let's go with something else. Let's get region and put that one on, we'll put it on shape again. So when it's a dimension or a categorical variable, I'm going to use either color or shape. And then I'm going to save size for other numeric features, because a bigger circle can represent a higher number. But I don't really want to do that with region. I don't want to have a region that's bigger than another region that's small. I guess if you want to represent geographic size, you could, but that's typically not what we're doing. So anyway, do we have a difference in each of these regions across all of them? Once again, it's hard to see, so I'm going to try and zero in like that and scroll in. All right, I got squares, circles, pluses, crosses in the blue. I've got circles, crosses, X's, and squares. So no, region's not really helping either. I'm going to pull that one out. All right, well, so much for our other two dimensions. Let's take a look at the measures. Let's try, let's start with children. I'm going to put children on size, so that way larger circles indicate more children. So now what I'm looking for is, does this middle section have all larger or all smaller circles? Well, once again, I'm seeing everything from large to small on the blue and large to small on the orange. I don't see that children is doing much good either here. My last one is BMI. Let's give that one a shot. All right, now BMI is pretty continuous, so it's tough. It's done this this grouping over here into 4 bins now, and I could potentially adjust maybe the size so that some are much smaller than others. Is that going to let me do that? No, can't really do much. I would love to change the max and the min size. I could probably do that if I figured it out, but just by looking at this, you know, I do see larger. Well, I still don't know for sure. I can't tell. So what I'm going to conclude from this, I'm going to pull BMI out. My conclusion then is that smoker clearly explains a lot of what's happening with this age chart, but none of my other features did. I don't have any feature that sort of was consistent across all values of these, or had some value that was always in the middle here and then different on the top and the bottom. So I'm going to conclude that I don't have the data to drill into this middle level, but I do have enough data now by including smoker to differentiate between this one and this one. So what I'm going to do is copy this chart and go back to my data exploration report. And I am going to, since it wasn't an interaction effect, it just simply helped explain some of the weird effects of age. I could put this in a number of places, but I think I'll put it here under age scatter. I'm going to put probably right here. I'll call it a 3D chart of charges, age, and smoker. All right. And I am going to add to my summary here. There are 2 groups who consistently cost more. maybe I'll add to this right here. We explored this relationship in greater detail by including every other feature in a 3D or 4D model. We conclude that only the smoker feature helps to explain these groups. Smokers consistently cost I should say completely comprised the highest cost group, while non-smokers comprised the lowest cost. However, the middle cost group was not differentiated by smoker or any other feature. We suggest exploring this further with new data. And this might be something that you would include maybe at the very end in implications or conclusions of the report, or key takeaways you could put here after the last detailed relationship and all that. All right, let's take a look at one more. If you recall, back here in Tableau, we had another issue here with BMI, where we have this group up here that seems to be breaking away from the rest. And this clump is also kind of, there's not really a clear direction here. It's one big clump. So let's see if there's something, another variable that's influencing this. I'm going to create another one here and call this MD BMI scatter. And let's go ahead and bring in BMI and charges again. Disaggregate data. Oops, let's flip those around. So charges on the Y. Okay. So once again, because we know smoker had the biggest effects, I'm just going to start right there and pull it in, put it on color. And look at that. That's pretty clear. Those who smoke at all levels of BMI have higher charges. So those who are smaller, it's adding higher charges, but there appears to be this compounding effect, or what we call an interaction effect. When I explained when I gave two explanations in the prior example, I'm referring to the first one, interaction effects, that I said didn't apply back here because the variance or spread was consistent throughout all levels. Here it's not. See how this angle, there's clearly a different trend line for the orange data than there is for the blue data. In fact, we can verify that. Let's pull in a trend line now, add a linear one. So look at the incredible difference here. Smokers have this sharp increase. As their BMI increases, the insurance costs, there's a synergistic effect between smoking and being heavier, meaning that it's not additive. If it was like it looks back here in the age chart, here it looks like smoking is just consistently always the same level higher in terms of costs at every level of age. So these two, age and smoking, are not interacting. There's just this additive effect. But over here with BMI, they are interacting. There's a compounding effect or synergistic effect. So there's a couple things we want to do from this. I would first of all include this chart in our data exploration report. So I'm going to copy that image and come back here to the report. Let's see here. BMI, perfect. So I'll put right here 3D scatter plot of charges, BMI, and smoker. Shrink that down a bit. Okay, and based on this information, there's something we can do to create a new feature that may help greatly in the modeling phase. It's called creating an interaction term. So it's going to be a new column that will account for this difference in trend lines between these two. So I would include in the write-up here, there is also a clear interaction effect between BMI and smoking. In particular, as BMI increases, the insurance cost of smoking increases exponentially. So notice our coefficients here for our power. We've got 3 coefficients here for BMI cubed and squared. If you remember this from the prior video, the trend line is going to totally change now for these two, and both of them are going to be far more significant than the other one was alone. Look at this one. Our p-value overall was small, but for each of these different coefficients, they were pretty big. And R squared was 4%, which is not super high. But now that we've accounted for smoker, our R squared just jumped up to 65%. So that's a 61% increase. From 4% to 61% is huge. And then this one is pretty low, and that's understandable, I think, because, see, this is the blue, all seems to be kind of a big blob still. P-value is still very small, so it doesn't mean it's totally useless, but maybe we could do better with a different trend line right here. So I could come in and say, all right, let's try a logarithmic for both. That doesn't help. It's still super high. Let's try exponential. Doesn't help. In fact, that hurts it. Polynomial. All right, this is, to me, feels like what's called overfitting. I think this line right here is the only one that matters, and our R squared's a bit better, but I don't think it's worth creating 3 terms for. This one's about the same. And then lastly, we'll try power. A little better, not a ton. This one's a bit better, but I think none of them are so much better that I'd prefer just to stick with the regular old trend line. So what I do to account for this, that I can get the value out of this right here, this increased R squared, is I need to make a new variable that simply multiplies BMI times smoker. Well, how do you multiply BMI times a yes-no word? Well, the way we do that is we have to have a version of smoker that, whoops, let me go back to Tableau. A version of smoker that is converted to a 0, 1. So a 0 will mean no, and a yes means 1. So I can do that actually right in here. I can create a calculated field, and let's just call this smoker numeric, and let's simply say if smoker equals yes, then we'll say this one should get a 1, else 0, end. Let's see if I did that right. Where did it put that for me? Smoker numeric right here. Perfect. 1, 0, 0, 0, 0, 0, and then here's our yeses. Okay, so now that I have that, I'm going to make one more calculated field. And this one is I'm going to call this one our BMI by smoker interaction. And this is simply going to be smoker numeric times BMI. All right, so here's our smoker numeric times BMI. And basically all this does is it says only count BMI if they are a smoker. Otherwise, don't even worry about BMI. Multiply it by 0. And what this does is we're getting rid of a whole bunch of variance here in BMI that is not explained by smoker. And as a result, it's going to make the effect of this variable right here much stronger than BMI was. So we don't know yet if this will be a better feature when we get to the modeling phase. But during data understanding, we create this now. Well, technically this could be part of the data preparation phase, which comes next as well, but I just didn't want to forget it before we moved on. It's something we want to create, and we'll see later on if this is going to be something that's useful for us. Okay, so that's handling interaction effects or 3D. When I say 4D, 5D, 6D, that just means we could go further and just check and see if adding anything else here to the mix helps explain something for us or improve R-squared values or things like that. But I think you get the idea, and we're going to call it good for now.